This comes out of section 5.2, horizontal asymptotes. So we're asked to find the vertical and horizontal asymptotes and sketch this function here. Rational function, relatively simple in that it just has a x plus 3 and an x minus 4, no squareds, cubes, anything like that. We do know that if we put in x equals 0, that we have a point at negative 3/4, and we also know that if y has to equal 0, x equals negative 3, so we have at least some intercepts that we could sketch. But as far as asymptotes are concerned, my non-permissible value is that x equals 4. So I do what's the limit as x approaches 4 from the right, what's the limit as x approaches 4 from the left of x plus 3 over x minus 4. Now, if I do it from the right, I'm putting in a number like 4.00001, and I'm going to have a positive number on top divided by a tiny positive number on the bottom, which means this thing is going to head towards infinity. So as x approaches 4 from the right, I do have a vertical asymptote. Now, if I try a number like 3.99999, I still have positive on top, but I have a tiny negative on the bottom, and it means I'm heading towards negative infinity. So on this side, I'm heading towards negative infinity, something like that. Now, to do the horizontal asymptotes, I have to say, well, what's the limit as x approaches infinity of x plus 3 over x minus 4? Even if you divide everything by x, all you end up with is 1 over 1. And so you end up with a horizontal asymptote at y equals 1. And so what does this graph look like? Well, as I approach infinity, it should approach that y equals 1 asymptote. So something like this. And approaches this vertical asymptote, passes through its intercepts, and approaches its horizontal asymptote. So, when you find separate pieces of information, they should fit together and agree with each other, not disagree. And that's what we have in this situation here. So if we're asked to do a very similar example for a different function, we have another rational function here. First thing I would do probably is have a look at it factored x minus 4 times x plus 3. There are two non-permissible values. Non-permissible values at x equals 4 and x equals negative 3, so something may or may not be happening there in terms of asymptotes. So I do the limit as x approaches 4 from the right, the limit as x approaches 4 from the left, the limit as x approaches negative 3 from the right and from the left. That will give me my vertical asymptote decision. So x over x minus 4 times x plus 3, we're going to have a positive over a tiny positive and another positive, and so we're heading towards positive infinity here. So we can have a little sketch that as x approaches 4 from the right, we are heading towards infinity. If you try the same thing except for as you approach from the left, so you're talking about numbers like 3.99999, you do have positive, but you have tiny negative here and a positive. So we do have approaching negative infinity, which again confirms we have a vertical asymptote going on at x equals 4. Try the same analysis for as you approach negative 3 from the right, like negative 2.99999, and you'll do the same type of thing. So we'll have a negative over a negative times a tiny positive, and it gives me positive infinity. So as I approach negative 3 from the right, approaching positive infinity, and if I do that same work just to save you a bit of time, we end up heading towards negative infinity on the other side. So we have something like this. Now if you find the limit as x approaches infinity of this function, x over x squared minus x minus 12, you might start by dividing everything by x squared, but you'll soon discover that when the degree is bigger on the bottom than it is on the top, that your horizontal asymptote is at y equals 0. And so as I approach positive infinity or negative infinity, I have an asymptote at y equals 0. Interestingly though, this graph actually passes through that asymptote right here in the middle of the something like this. It agrees with everything we've said so far about asymptotes. It does have a vertical asymptote, x equals -3 and x equals +4. Horizontal asymptote at y equals 0. Kind of an interesting example in that it is a concrete example of something that crosses its horizontal asymptote.